Look at your monthly software bills: $10 for a password manager, $50 for workflow automation, another tier for analytics dashboards. In isolation, all these subscriptions look cheap, but because they bill by the user or by the execution, the stack quickly turns into a scattered, compounding financial drain. Renting a virtual private server changes the math. Instead of leasing 5 separate pieces of software, you rent a single piece of digital real estate at a flat monthly rate and consolidate those scattered workloads onto one machine. But you shouldn't try to migrate your entire business at once. The most practical way to start is by replacing one high-value tool, learning the maintenance routine, and building up from there. Today, we are going to deploy Vaultwarden. It is a lightweight, self-hosted password manager that requires very few system resources to run smoothly. After all, passwords are your most sensitive data. Putting them on infrastructure you own rather than a vendor server is the clearest way to prove why the flat-rate server model works. Step 1 is gathering the raw materials. You need 3 things: a domain name, a baseline Linux VPS, and a way to access your server's terminal. Because you own the server, you also own its maintenance. No vendor is going to manage your updates or your uptime. Total control over your deployment requires taking total responsibility for keeping it secure. We start by building a wall. On a fresh Ubuntu server, that means activating UFW, the uncomplicated firewall, to block unwanted traffic before it even reaches your applications. You only want to expose what is strictly necessary. We will punch exactly 3 holes in this firewall: port 22 for your secure shell access, port 80 for standard web traffic, and port 443 for encrypted connections. Everything else gets dropped. Run a status check in your terminal to verify those rules are active. You need to see those 3 specific ports listed as allow before moving forward. Establishing that rigid perimeter is the mandatory first step. We never install application logic on a machine that is wide open to the public internet. Right now, we need to install Docker. Think of Docker as a runtime engine that gives every application its own isolated container, ensuring your tools never interfere with each other's dependencies. To manage those containers, we use Docker Compose. This lets us write a single YAML text file that acts as the master blueprint for our entire server environment. Inside that file, we write our first instruction, telling the Docker engine to pull the Vaultwarden application image and allocate its memory. We also map it to a persistent volume. Containers are meant to be destroyed and replaced, so your encrypted passwords must live in this separate persistent storage layer. That ensures your data survives server reboots and application updates. Next, we add Caddy to our blueprint. Caddy acts as a reverse proxy. It sits in front of Vaultwarden, intercepts the web traffic, and automatically provisions the TLS certificates needed for secure HTTPS encryption. For Caddy to do its job, your domain's DNS-A record must already be pointing to your server's public IP address. Without that external connection, the encryption will fail. By defining our network, storage, and services in this one text file, we have completely separated the application setup from the hardware. If you ever change servers, you just move this file. With the blueprint saved, type Docker Compose up and hit Enter. The Docker engine reads the blueprint, pulls the images, configures the network, and locks the architecture into place. Open your web browser and type in your custom domain name to verify the deployment. Your new private password vault should load immediately. Look directly at the address bar. That locked padlock icon confirms your reverse proxy successfully secured the connection. But having a live, secure application brings us to the biggest operational danger of this setup: the consolidation of your data risk. If this virtual server fails, or you accidentally delete a directory, your application and every single password inside it vanishes instantly. You no longer have a vendor's support team to restore your account. This creates the golden rule of self-hosting. You must schedule an automated backup routine that copies your persistent data volume to an entirely different off-server location. Self-hosting without a verified external backup protocol migrates your risk from a corporate balance sheet to your own single point of failure. By securing that server and writing that blueprint, you now operate a private, high-value utility entirely outside the vendor lock-in ecosystem. Because your runtime engine and secure proxy are already active, adding new tools becomes highly efficient. You can drop Grafana, N8N, or Nextcloud right into the same server. You are no longer paying by the feature tier or the team seat. Expanding your private cloud to handle complex automation or massive file storage triggers 0 new software subscriptions. To launch your private app stack, start by deploying a fast, reliable server with Voxfor VPS. They offer global locations and room to scale exactly when your self-hosted setup needs to grow. Mastering the virtual private server provides a fundamental upgrade to your operational sovereignty, keeping your data under your direct control.